If you're like me, when someone uses the term legacy code, you probably think of code running on some scary mainframe in the dark basement of a gloomy government building, written in some crazy programming language nobody even remembers anymore, and you have nightmares about being asked to enhance that code. Well, that's a bit melodramatic, but you get the idea. But one point we tried to drive home at the very beginning of the course is that you should be proud to have your code be referred to as legacy code because that means it's still delivering value to some customers. Alarmingly often, when asked to enhance legacy code, the response of many programmers is, let's first rewrite it using modern languages and tools, then it'll be easier to enhance. Well, maybe it would be easier to enhance if it used modern languages and tools, but that legacy code has a big advantage. It works. It contains code and bug fixes that might reflect hundreds of thousands of hours of operation in the field under real working conditions. And programmers are hopeless optimists when it comes to estimating the difficulty of getting a big piece of code written. I like to use the 90-90 rule. Getting the first 90% of new software working takes 90% of the time. Getting the last 10% working takes the other 90% of the time. So, if your code is destined to become legacy code, and we hope it will, someday it may be someone's job to maintain and enhance it. So you should make your code as easy as possible to maintain and enhance. The good news here is that the same techniques we use to develop good code can also be applied to modify and enhance legacy code. In particular, having a solid set of tests so that you know immediately if your enhancements are breaking anything is so important that Michael Feathers, the author of Working Effectively with Legacy Code, defines legacy code as code without tests. In this module, you'll learn how to apply the agile techniques you already know to the task of exploring a legacy code base with the goal of enhancing it in some way, starting with how to create tests to cover the parts of the code you plan to modify. Most importantly, you'll learn how to refactor code, that is, improving its structure while preserving its functionality, since refactoring is often a prerequisite step to adding new functionality. If refactoring improves the structure of code, that implies that good structure can be measured in some way. You'll learn about both quantitative metrics you can run on your code to assess various aspects of its structure, and qualitative characteristics, sometimes called code smells, that indicate potential maintainability problems. And, of course, you'll be introduced to tools that not only help you identify those quantitative and qualitative issues, but even run automatically on any new code that you write. Initially, you may be surprised at how much overlap there is between agile techniques for creating high-quality new code and those used for maintaining and enhancing legacy code. But it may be less surprising if you consider that agile is all about embracing change, and enhancing long-lived legacy code is just embracing change on very long timescales.